All right, so we saw that the number of protons determines what element we have. If we have a different number of electrons, then we have an ion. And then finally, we can have isotopes. So in isotopes, we have the same number of protons. So we have the same element. But we have a different number of neutrons. Some elements only have one naturally occurring isotope. Others have more, usually no more than 3 or 4, but it really varies, right? So isotopes, same number of protons, you have the same element, but sometimes they have a different number of neutrons. So let's take a look at an example. Neon has 10 protons, and if you check out a periodic table, you will see that is hopefully correct. Hopefully I'm not making that big of a mistake. And so it's always found with 10 protons. If you have 10 protons, you're neon. It doesn't matter how much of whatever else you have. But neon can have either 10 neutrons, 11 neutrons, or 12 neutrons. And so we call these different isotopes. There's different ways we can indicate these isotopes or write out these isotopes. One is we just give the chemical symbol, so Ne, and then a dash with the number of protons and neutrons combined. And that's called the mass number. It gets the symbol capital A, and it's equal to the number of protons plus the number of neutrons, right? So in this case, neon 20, we know neon has 10 protons. Thus that isotope must have 10 neutrons as well. We can also have neon 21, so still 10 protons, but now 11 neutrons. And then neon 22, still 10 protons, but now 12 neutrons. So that's one way to write it out. Another way to write it out is in this format where we have X is our symbol. So that'd be Ne in this case. On the top left, we have the mass number. So that's the protons plus the neutrons. And then on the bottom left, we have the atomic number, which is just the number of protons. So we can write these as neon on the top left. We can write this as 20 and 10. Neon 21 and 10, and then neon 22 and 10, right? Where these top numbers are our mass numbers, and that's equal to the number of protons plus the number of neutrons. And then the bottom left is your atomic number. So remember, that's the atomic number that gets the symbol capital Z, and it's just equal to the number of protons. Sometimes the atomic number is omitted. So you might see something like neon and then just like a 22 on the top left. The reason that it's omitted is because if you have neon, you know that you have 10 protons. There's no other element that could possibly have 10 protons because 10 protons means neon. And so it's just a bit of a redundant piece of information. And so again, if we wanted to know the number of neutrons, we would just take our mass number, which is protons plus neutrons, and then subtract out our atomic number, which is just the number of protons, right? So for example, if we had neon 22, 10, we would then just take 22, subtract out 10, and get 12, right? This has 12 neutrons. Let's take a look at another example. So what if we had 52 on the top, CR as the symbol, and then a 2 plus to the top right, a little bit of a twist there for you. So first thing you're going to need is your handy dandy periodic table, unless you've somehow got it memorized, which would be quite impressive. I didn't even bother to memorize the periodic table. But that's because I'm an organic chemist and we use about 10 elements, and that's pretty much it. Anyways, continuing on to the relevant information. First thing we identify is that we're not given the atomic number, right? We don't know how many protons there are just off the top of our head. And our question might ask, how many protons do we have? How many neutrons do we have? And then how many electrons do we have? Well, we know chromium is an element, and we know that each element has the exact same number of protons. So we just look at our periodic table, find our atomic number. In this case, it's 24, right? So we know that we have 24 protons. because every single chromium has 24 protons. Then we can take a look at the number of neutrons. We see on the top left is our atomic, or my bad, the mass number. And so that'll just be the protons plus the neutrons. So if we wanted just the neutrons, we would take this number and then subtract out the number of protons that we have. And so then we'd be left with 28 neutrons. And then finally, the number of electrons that we have to think about our charge here. So in this case, our overall charge is +2, and our charge is going to be equal to the number of protons, which we said was 24, minus the number of electrons. And then we can do the math there, or you can just think about it logically, and you'll come up with 22 electrons, right? So given this type of symbol, be able to identify how many protons, how many neutrons, how many electrons you have. And again, this is all practice. Another type of question that you might see is something maybe like, I'll give you an X here, and then let's go with 12 and then 6, and then I'll ask you to identify what's the identity of X. So in this case, we see that it has 6 protons, so then we just go over here up to 6. We know X is carbon. Again, practice, practice, practice.